Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0192, indicates a low voltage issue in the fuel rail pressure sensor circuit within Honda Civics manufactured between 2011 and 2015. The fuel rail pressure sensor plays a crucial role in monitoring the pressure of the fuel in the fuel rail, signaling the powertrain control module, PCM, to adjust fuel delivery accordingly. This sensor is primarily located near the fuel rail, which is a significant component in the fuel delivery system. If the fuel rail pressure drops below the expected threshold, it can lead to engine performance issues and increased emissions. Accurate diagnosis and repair are essential to ensure optimal vehicle performance. This presentation will guide you through a detailed troubleshooting process to resolve DTC P0192. The error associated with DTC P0192 pertains to a low voltage condition within the fuel rail pressure sensor circuit. The fuel rail pressure sensor is responsible for measuring the fuel pressure within the fuel rail. This measurement is essential as it informs the PCM about the fuel delivery pressure, allowing for necessary adjustments to optimize engine performance. The sensor is typically positioned on the fuel rail, allowing it to accurately monitor the fuel pressure directly. If this sensor reports a voltage of approximately 0.23 volts or less, as would be indicated during diagnostic testing, this signifies a potential problem with the sensor or its circuit. Accurate diagnosis is crucial to addressing issues related to fuel delivery and engine performance. Several potential causes can lead to the DTC P0192. First, poor connections or loose terminals at the fuel rail pressure sensor or the PCM can disrupt the electrical signals necessary for the sensor's operation. These disruptions may manifest as low voltage readings. Additionally, a faulty fuel pressure sensor could lead to incorrect voltage signals being sent to the PCM. It's also possible that issues extend beyond the sensor itself to wiring faults in the circuit. Each of these potential causes must be explored systematically to pinpoint the source of the trouble code accurately. When DTC P0192 is triggered, several symptoms may manifest, impacting the vehicle's overall performance and reliability. Drivers may experience noticeable engine performance issues, which can include stumbling, stalling, or reduced power output, as the PCM struggles to make the necessary fuel adjustments. Additionally, there may be an increase in emissions due to improper fuel delivery, resulting from faulty sensor readings. Furthermore, the vehicle's onboard diagnostic system may illuminate warning lights or indicators related to engine performance and fuel management. Recognizing these symptoms is critical for timely diagnosis and reparation. The first step in troubleshooting DTC P0192 involves verifying the initial problem. Begin by turning the ignition switch to the on-to position without starting the engine. This activates the vehicle's electronic systems, allowing for diagnostic checks. Using the Honda Diagnostics System, HDS, check the fuel rail pressure, FP, sensor readings. If the voltage is approximately 0.23 volts or less, this indicates that the failure is confirmed. If the voltage is higher than 0.23 volts, it may suggest an intermittent issue, and additional checks for poor connections or loose terminals at both the fuel rail pressure sensor and PCM should be conducted. In the second step of troubleshooting, begin by turning the ignition switch to the lock 0 position. This is crucial as it ensures that all electrical systems are powered down, allowing safe disconnection of components. Next, disconnect the fuel rail pressure sensor's 3P connector. Again, turn the ignition switch back to the on-to position. Using the HDS, check the FP sensor readings. If the voltage now indicates approximately 0.23 volts or less, proceed to the next step in the troubleshooting process. If not, Further investigation should focus on other components that may be affecting the voltage output. In this third step, the goal is to confirm the health of the voltage supply to the fuel rail pressure sensor. With the ignition switch in the lock 0 position, measure the voltage between defined test points while ensuring that the fuel rail pressure sensor is disconnected. Specifically, you will measure between test points 1 and 2, using the black wire on the sensor's 3P connector as test point 1 and the red wire as test point 2 under ignition on. Conditions. A voltage measurement close to 5.0 volts indicates that the sensor circuit is functioning normally. If this value is confirmed, it is advisable to replace the fuel rail pressure sensor as it may be defective. However, if the voltage is not approximately 5.0 volts, further diagnosis is required in the subsequent step. The fourth step focuses on checking for potential open circuits within the voltage supply line to the fuel rail pressure sensor. Start by switching the ignition to the lock 0 position. Then use the HDS to jump the SCS line, allowing specific diagnostic functions. Disconnect the indicated connectors, specifically the VCC6 and SG6 connectors, along with the fuel rail pressure sensor's 3P connector. Now, check for continuity between specified test points while ensuring the sensors are disconnected. If continuity exists, this indicates that the VCC6 wire is intact and functioning correctly. If continuity is confirmed, consider updating the PCM software or substituting with a known good unit if necessary. However, if no continuity is found, this suggests an open circuit in the VCC6 wire, thereby necessitating repairs. The fifth troubleshooting step involves checking for potential short circuits in the PF2 wire leading to the fuel rail pressure sensor. Begin by ensuring the ignition switch is set to lock 0 and once again executing the SCS line jump with the HDS. Disconnect the PCM connector A49P to isolate the circuit. Measure continuity between the indicated test points under the specified conditions. This involves checking from the PF2 connector to body ground. If continuity is present, it suggests that the PF2 wire is shorted and repairs will need to be made. If there's no continuity, the wire is confirmed as intact, and it may be necessary to update the PCM software or replace it if further issues persist. After completing repairs related to DTC P0192, it's crucial to verify that the issues have been resolved. Start by ensuring all connectors are securely reconnected. With the ignition switch positioned to on, 2, reset the PCM using the HDS, which clears any stored faults and prepares the system for normal operation. Proceed to perform the PCM idle learn procedure, allowing the system to recalibrate and optimize performance settings. Finally, check for any pending or confirmed DTCs with the HDS. If DTC P0192 reappears, investigate for potential loose connections around the fuel rail pressure sensor and PCM. If the PCM was updated or substituted, ensure you record these actions accurately for future reference. Preventive maintenance practices are integral in ensuring the longevity and reliability of the fuel system in Honda Civics. Regularly checking and securing all electrical and connection points, especially around the fuel rail pressure sensor and PCM, can prevent voltage-related issues that lead to trouble codes like P0192. Additionally, keeping the PCM updated with the latest software enhances system performance and compatibility with newer components. It is also advisable to perform periodic maintenance on fuel system components, including filters and injectors. Such proactive measures can reduce the risk of failures, enabling smoother operation and maintaining optimal engine performance. In summary, DTC P0192 signals a low voltage condition within the fuel rail pressure sensor circuit, prompting a structured troubleshooting approach. The process begins with verifying the issue, locating the sensor, and systematically checking voltage across various components. Potential causes include wiring faults and sensor malfunctions, each requiring thorough examination for precise diagnosis. Addressing symptoms such as engine performance issues or increased emissions is essential. Furthermore, establishing preventive maintenance routines can significantly mitigate the occurrence of such trouble codes in the future. By adhering to these guidelines, vehicle owners and technicians can ensure optimal functionality of the fuel delivery system and overall performance of the Honda Civic. Please like and subscribe to the channel. See you next time.